Welcome to this Digital forensics is a field that involves the identification, preservation, analysis, and presentation of digital evidence. It is a crucial part of modern criminal investigations as more and more crimes are committed using digital devices or through the internet, right? So, here one of the main goals of digital forensics is to acquire evidence. Acquiring evidence in a way that preserves its integrity and authenticity. Yes, this is important because digital evidence must meet certain legal standards. So, in order to be admissible in court, let's take an example. The evidence must be collected in a way that ensures it has not been altered or tampered or deleted. Okay, and it must be handled in a way that preserves its chain of custody. We'll come to know what is this chain of custody in upcoming sessions. So there are many different tools and techniques that are used in digital forensics, which may include forensic software, specialized hardware, and expert knowledge of computer systems and networks. Some common tasks in digital forensics, which includes recovering deleted files, obviously, and analyzing the network traffic and examining the contents of digital devices such as computers, smartphones, and tablets. So digital forensics is important. Why? Because it allows law enforcement and other organizations to investigate crimes and gather evidence that can be used to prosecute offenders. And it is also a valuable tool for businesses and individuals who need to investigate cyber attacks or other security breaches. So overall, in conclusion, the digital forensics plays a vital role in modern investigations and is an essential tool for law enforcement and other organizations. Hence, it is important to properly acquire and preserve digital evidence in a order to ensure that it can be used effectively in court. Okay. So, for those who are not familiar with or new with the FTK Imager tool, let me make them understand. It is a fairly robust and widely used and recognized imaging tool which is used throughout the digital forensics community. Understood? Okay, if not, let's make it more and more simple. In simple terms, to make you all understand easily, FTK Imager, that is the Forensic Toolkit Imager, it is a digital forensics tool which is used to acquire and analyze digital evidence. So it is a software program that allows user to create forensic images of digital devices. Forensic images are nothing but the copy or duplicate of a file, such as computers, smartphones, and tablets. These images can then be analyzed and examined in order to gather evidence for use in criminal or civil investigations. Okay. So it is provided to us by Access Data, but now it is acquired by the Extero company. Okay. So the FTK Imager runs as a standalone application, or it can be run as FTK Imager within the USB or portable device environment. It has some specific functions, and those are the areas that we are going to discuss. So throughout this course, we will of course be talking about the attributes and the usage of FTK Imager. But before that, let's check out some additional points to consider about FTK Imager and its role in digital forensics. So the first is FTK Imager creates a forensic image of local hard drives, CDs, DVDs, or an entire folder or individual files within the media. One of the largest aspects of FTK Imager is its ability to capture a forensic image. This is a bit-by-bit copy of a suspect's machine. Next, capture volatile data and protected data from a Windows machine, which includes things like registry, files, and RAM. And a third area of interest, and again a very important part of what it provides to us, is the ability to view and analyze captured images and preview files and folders and contents of the forensic image. Next, mount an image for a read-only view, that is, to see the content of the captured image exactly as a Windows Explorer. Number 5, it helps in export files and folders from the forensic image or forensic copy. And also see the recovered files that have been deleted from the recycle bin but have not been overwritten or formatted from the disk. FTK Imager comes with a wide range of different options available to you for the types of images or copies that you want to create. For example, it also provides the function of hashing. So hashing is nothing but it is a technique or process of transforming any given key or a string of characters into another value. It also creates hashes of files using the two hash functions available in FTK Imager, that is MD5 message digest 5 and SHA1 secure hash algorithm. It also generates hash reports for regular files and disk images, which including files inside disk images, which will help to prove the integrity of the case, evidence, or the image you have just captured. And there are several ways, in fact, that you could do this, either as a quick triage or data as a bit by bit analysis, which will allow you to look at things such as slack space and deleted items. Hello, Afrozullah Khan here. In this class, we will look at the installation of the FTK Imager interface. Now, most of this module will be based on the practical of installing the FTK Imager. So, installing on the Windows desktop or your workstation, I'm pleased to tell you that it is a relatively straightforward and easy process. But first and foremost, you must visit the exterior site in order to find the download link on the website. You will also be able to find other resources available to you on the exterior website, such as release notes and up-to-date user guide for the version that you are downloading. And even in the FTK Imager, after downloading, if you go for the help section, there you will find the user guide. Even there you can access the same thing. So no worries, you can either download it from FTK Imager or you can visit the website. I'm glad to tell you that no need of that user guide. Why? Because you are going to learn all the things in this course from A to Z. So I can say that no need of any user guide if you are done with this course. Okay, so coming back, once after visiting the website of Exterior, once you have located the download link, it is a relatively simple sign up process, but we will need to provide a valid email address. We need to fill the form. We need to provide our name, email, organization, and our designation, etc. Once you have followed the link, you can then install it onto the local drive. Once that is successfully installed, you can then go ahead and configure your interface. So coming up, we are going to take a demonstration and a look at all of these features in the process of installing FTK Imager onto your Windows workstation. We are then going to have a quick overview and explore and configure the interface. Okay. And so for this demonstration, I'm using a Windows 11 professional client, and it is a 64-bit version of the operating system. Now most of the operating system is 64-bit nowadays, but even we have 32-bit version of the operating system. Even I used to have. So if you are going to run the FTK Imager, so keep that in mind, you need 64-bit operating system. The reason why I am using 64-bit and why you have to use 64-bit operating system, in the sense, starting from the version 3.4.2 of FTK, the FTK Imager is now only available as a 64-bit application. Okay, before that we used to get 32-bit and 64-bit as well. Both versions will easily downloaded from the website. If your system is 32, then you can download it. If your system is 64, you can download the 64 version. But starting from 3.4.2, the FTK is coming only, and it is available only for 64-bit application. So please use 64-bit applications. Okay. So browse to the FTK Imager setup file by visiting Exterior site. Remember, I said you that this will ask me to register by using a valid email address. Once you have downloaded it, you can then select it from the download folder, which will then allow you to go through the normal process of installing that locally onto your machine. Click download to download the latest released version of FTK Imager. Browse to the location where you wish to save the install file and click save. So when the download is complete, browse to the location where it was saved. Now execute the setup file by double clicking it or right click and run as an administrator. On the welcome screen, click Next. Read and accept the license agreement, then click Next. Do one of the following. Accept the default installation location. Browse to a different destination folder. Okay, so I'm going to go ahead and do just that. It's a good idea to notice the location of the path to which it's being installed. Program files and a folder is going to be created called FTK Imager. Okay. Then let me click Next. In the ready to install screen, click Next. Once the installation has taken place, which won't take very long at all, you get the option to launch directly to FTK Imager. I'm going to go ahead and do just that. Once the application is launched successfully, you can see that it goes into the default view. So do one of the following. Mark the launch access data FTK Imager box to force Imager to run immediately after the installation is complete, or else you can leave the box unmarked to run the newly installed program at a later time. So this is about the installation of FTK Imager. Now the FTK Imager has been installed on our workstation. Okay. So installing FTK Imager on a USB drive. Hello, in this section we will be looking at installing FTK Imager on a USB drive. There are several good reasons why running FTK Imager from a USB drive are good options at the scene of an incident, not least the fact that it can be run from a portable USB drive, that is pen drive, allowing for imaging of a suspect's computer or your target computer without the need for installing the software on the target machine or the suspect computer. This can be useful in forensic investigations as it allows for the preservation of the original evidence in its native state or original state. So running FTK Imager from USB drive, it will remove the risk of locally installing on a suspect's computer. Okay. However, in fact, you will always use a write blocker between your USB drive and the suspect's machine. Having it on a USB portable device will make the application portable, and so it can then be used multiple times on multiple devices. And even it runs with minimal overhead, and therefore it is a very efficient way of conducting the operation. Actually, installing FTK Imager onto a USB device is very straightforward, as we saw in section 1. It is a relatively straightforward thing to install the FTK Imager itself onto your forensic workstation. In doing this, you can then insert and format the flash drive partition with FAT32 or NTFS. So there are two ways to use Imager on your portable device. One is copy the FTK Imager files directly to the device, avoiding installing to a local computer first. and install FTK Imager on the forensic workstation. Okay, and later on run the installation on your local computer, then copy the entire FTK Imager folder from that system to your USB portable drive. Okay. So now we are on our computer screen, our workstation. So already the FTK Imager has been installed on this workstation and it is working fine. So let me uninstall this. Let me open the control panel and uninstall a program. Let's wait. Before uninstalling, we need to copy the folder. If we uninstall, the entire folder will be deleted from the system. So before uninstalling, let me copy this. Let me open local disk D, and this is FTK Imager. So we need to copy this entire files into the USB. Okay. So what I will do is I'll just go back and copy this FTK Imager folder, and next let me open this USB drive just connected to the system. Let me paste this. Now successfully we have pasted the FTK Imager folder to the USB. So the properties we can see here. So the entire folder we have copied, we have the files, everything. So before opening the FTK Imager from USB, let me uninstall the FTK Imager from the system. So let me open the control panel, uninstall a program. So we have the access data FTK Imager. Okay, let uninstall. Yes. So successfully we have uninstalled the FTK Imager from the system. Now let me open the USB drive and FTK Imager folder. Now let's run the FTK Imager exe file. Okay. So yeah, local disk D, we have this FTK folder. Let me delete this entire folder from here. Okay, so we have deleted. Now let me go to USB drive, open FTK Imager, open. Now let me find the FTK Imager exe file. Okay, right click and run as administrator. Boom. Now we have successfully running the FTK Imager using USB drive, and we have successfully installed the FTK Imager to the USB portable device. So now this USB can be connected to any system in order to take the imaging of it. So it is working properly. Yeah. So this is about installing FTK Imager onto the USB drive. I hope you have understood how to install this. As the FTK Imager program files are saved to the portable media, that is USB, that media can be connected to any computer running a Windows operating system, and the program file, okay, that is FTK Imager.exe, can be executed from the portable media device. With either method, you will need to make a target drive available for saving the image data, and a reliable write blocker must still be used. It is a good idea to create separate partitions and maybe make a tools folder where all of your forensic tools could then sit, including the FTK Imager. Coming to the USB considerations, of course there are several things that we need to consider when using USB devices at the scene of an incident. First, that is, USB access may actually be restricted. This may actually be denied USB ports or the USB port themselves are full, in which case you would need to have some kind of backup plan. And next, running the application will actually have an impact on the target machine, which is why a write blocker is essential. You may then also need to consider storage requirements. In some cases, you may have a separate partition where you can run your forensic tools, and also then have a partition where you can actually store the evidence items. However, in other cases, you may choose to have separate devices for each. So here are some checkpoints. Regardless of what your actions are, you should always ensure that the portable USB drive used to run FTK Imager is properly formatted and has enough storage space to save the forensic image. Okay, and also ensure that they are recorded and properly audited, and this is very important when we are plugging USB devices into suspect machine. You should also consider using a powered USB hub and maybe make that part of your go bag. So please make use of USB hub. And verify the integrity of the forensic image created by FTK Imager by calculating its hash value and comparing it to the original device's hash value. And follow standard forensic protocols and procedures when using FTK Imager, such as maintaining a chain of custody for the evidence. Always make sure that the device you are imaging is secured and you have the right to access it, following your company or organization policies and law. Of course, it is always a good idea to be conducting risk assessments before you do any action and when you are working on a suspect machine. Keep good documentation of the imaging process, including information on the device image, the data and time of the imaging, and the person who performed the image. You never really know what the impact is going to be as soon as you start plugging in devices and are indeed running applications. Of course, as with all of this, it's a good idea to have tried and tested incident response plan, which you are going to stick to. And part of that plan would be, of course, a backup plan that you need to put into place. Okay.
So now FTK Imager user interface, the UI of FTK Imager. Now we can take a look at the basic panes and menus, that is FTK Imager user interface and options, which is available in the FTK Imager dashboard. So the FTK Imager user interface is divided into several panes. Each is dockable. Okay. You can see that there are 4 options available to me, that is file, view, mode and help. They will be discussed in detail in this section. And a toolbar which gives me the same as the file menu, but this time in an iconized form, and can all be undocked and resized to best fit your needs. and followed by the evidence tree, file list, properties with hex value, interpreter, and custom content sources panes and viewer pane. Each can be redocked individually, or you can reset the entire view for the next investigation. So for example, let's undock a pane. So to undock a pane or toolbar, first select any of the pane. Let me select this. Select it and click and drag its title bar. Okay. So you have to drag the title bar to the desired location wherever you want to fit. And again, to redock a pane or toolbar, do the same thing. Just drag the pane inside the FTK Imager window until you see an outline or the shape snaps into place in the desired position, and then simply release the pane. So it is as simple as that. So after rearranging all these things, so to return all panes to their original positions, you need not to rearrange or move from one place to another. To bring its original state, just simply go to the select view and click on reset docked windows. That's it. As simple as that. Next is menu bar, like menus and toolbar. So use the menu bar to access all the features of FTK Imager. The menu bar is always visible and accessible. So there are 4 items on the menu bar, that is file, view mode, and help. The toolbar contains all the tools, functions, or features that can be accessed from the file menu, except exit. You will not get the exit option in the toolbar. You have to go to the menu bar. Okay. And coming to the view panes, there are several basic view panes in FTK Imager. They are described in this section. So there are 4 separate panes that are available to me, like evidence tree pane, file list pane, combination pane, properties, hex value interpreter, custom content sources, and viewer. As we saw, there are 4 items on the menu bar: file, view, mode, and help. Let's discuss about the file menu. The file menu, which provides access to all the features you can use from the toolbar. The file menu will give me most of the control that I need in order to, for example, add evidence items or mount different images, etc. It also allows me to capture by creating the disk image or captured memory and protected files. These are some of the key areas that we will meet in the next module. And view. Okay, the view menu allows you to customize the appearance of the FTK Imager, including showing or hiding panes and control bars, etc. Under the view panes, I am able to customize the appearance of FTK Imager by changing and selecting the different tools and indeed the different panes which are available to me. Mode. The mode menu lets you allow to select the preview mode of the viewer. Each of the viewing mode is discussed in more detail in upcoming sessions. The mode option allow me to convert between text and hexadecimal when I am viewing files in the viewer pane. You will be easily understand when we are actually working on the evidences and all. That time you will come to know what this text and hexadecimal. Okay. Next is help. Help will give me all important user guide information of the course and about FTK Imager also. Coming to the evidence tree, the top upper left is the evidence tree. Will then allow me to see or display added evidence items in a hierarchical tree attached to evidence or mounted drives. So just click the plus sign next to a source or folder to expand the view to display its subfolders. And you have to click the minus sign next to an expanded source or folder to hide its contents. When you select an object in the evidence tree, its content are displayed in the file list. The properties of the selected object, such as object type, location on the storage media, and size, are displayed in the properties pane. Any data contained in the selected object is displayed in the view pane. This then allows me to then select from the file structure so that I can then view them in the file list. Coming to the file list, the file list pane shows the files and folders contained in whichever item is currently selected in the evidence tree. It changes as you select, as your selection changes. Okay, and then this file list highlights and shows me selected items, and these are then represented in the view pane in the bottom right hand section. This will then show me the content of a selected file from the viewer. Coming to the third section, that is combination pane. So the FTK Imager lower left pane has three tabs. You can see that there is a properties, hex value interpreter, and custom content sources CCS, which allow me to then filter all attached images. So the properties section have the property tab display a variety of information about the object currently selected in either the evidence tree or the file list. And the properties include information such as object type, size, location on the storage media, flags, and timestamps. Hex value interpreter. The hex value interpreter tab converts hexadecimal values selected in the viewer into decimal integers and possible time and date values. And custom content sources have the each time you add an item to be included in a custom content image, it is listed here. I could then create my own custom content images, and this is something that we will discuss and review later in the course. You can add, edit, and remove one or all sources and create the image from here. So the viewer shows the content of the currently selected file based on the preview mode selected, natural or text or hex. The hex value interpreter tab converts hexadecimal values selected in the viewer into decimal integers, and the content can be scrolled through so you can see the entire file content. In addition, with hex mode selected and the combo pane hex value interpreter, open the hex interpretation of text selected in the view pane can be viewed simultaneously. Once again, from the default values, you can either choose to select a file to control FTK or use the menu list icons. The choice is entirely up to you. So this is all about the FTK user interface. This is about the dashboard. If you understand this, it is easy to work on the FTK Imager. Okay, that's it. capturing volatile and protected data using FTK Imager. So here we will capture the volatile data from a live machine. So before doing any of the practicals, let's understand a little bit of it. Okay. So hello and welcome everybody. In this lecture, we will be looking at capturing volatile and protected data using FTK Imager. So FTK Imager is primarily used for creating forensic images of storage devices. That means copy of any storage media. But it also has the capability to capture volatile data from your live machine. So this can be done by using the acquire or capture memory. This is the option which is available in the FTK Imager, that is called as acquire or capture memory. Okay, so using this option, we will capture the RAM of the system. So this acquire or capture memory option in the FTK Imager software is available. So when this option is selected, the FTK Imager will create a memory dump of the live machines, that is RAM, random access memory, which can be analyzed for evidence purpose. So now coming up in this module, we will be talking first and foremost about capturing volatile data from a live machine. And initially we are going to take a look at some of the points that we need to consider before capturing the RAM. So this will be things such as the order of volatility and the risk assessment that we would need to understand when we are dealing with a live forensic situation. Then we are going to have several demonstrations there where we will be looking at capturing the volatile data in the form of RAM. And then having a look at capturing the protected or registry files on a Windows machine. So first and foremost, let's discuss about this. Capturing volatile data from a live machine means it is very important to highlight that we are talking about the order of volatility from a local live machine. So this would also of course include things such as system caches and network caches, and of course the RAM, random access memory. So now in my experience, there are several points of view as to whether or not collecting the RAM from a live machine is a worthwhile experience. But I would suggest, if it does not hamper your investigation and you have the means to do so, for example with FTK Imager, you should take it. For that reason, it would then be able to be analyzed should it be required if you don't take it. And of course, once you deadbox the machine, that means once the system is turned off, you won't be able to gain access to it again. Access in the sense the random access memory, which will be present in the system while it is running. So once the system is turned off, then you won't be able to gain access to it again. So there are other resources which would be part of this consideration, such as network-based resources. For example, those are stored in the cloud. And as soon as you then remove the network from the machine, then you will invariably also lose access to cloud-based resources. And other non-volatile areas that you need to consider, such as system settings, Windows registry, and like external and internal storage in the form of drives. And of course, FTK will help you with the majority of this. Okay. Then regardless of your policies here, it is very important to make sure that you work to a plan. And invariably, of course, this would be your instant response plan while capturing the RAM. And there are several different policies that you may adopt, and depending on the situation you find yourself in. And it is important to avoid uncertainty and doubt to make sure that you are competent and confident in what you are doing on the live machine, and that you always have to. and then record your actions. This is absolutely paramount from the beginning of your investigation when it starts right way through the end, and would be part of your chain of custody also. And be aware of the different risks that are involved with dealing with the live machine. And indeed, if you are going to be using a USB drive with FTK Imager on for the collection of data, so we'll suggest have to use a write blocker. The write blocker has to be used between the USB device in which the FTK has been pre-installed and the suspect machine. So it has to be the bridge between the USB device and the suspect machine. So the form of write blockers, like we can take example of the forensic bridges called Tableau. Okay, so it is the best known family of write blockers called Tableau, which ensures the integrity of digital evidence. So basically the Tableau forensic bridges, which permits read-only access to data storage devices without compromising the integrity of the data. So hence we have to use the write blockers between the USB device and the suspect machine. Okay, and check, you should always make sure that you will check your results. Okay, there is nothing worse than going through our lengthy procedure in collecting the data only to find that your hard drive has not recorded them, or indeed that the results are corrupt. And it's absolutely essential to make sure that you record and hash your results to maintain the digital integrity of the evidence that you are collecting. And this of course would also form part of your chain of custody also. Coming up then, we are going to discuss and have a demonstration about collecting RAM from your live machine using FTK Imager. Okay. Capturing RAM from a live machine. So in this demonstration, we will be capturing RAM from a live Windows machine. First, we are going to conduct a RAM capture using FTK Imager, and I shall be using that from a USB device onto the target or suspect machine. So I have pre-installed the FTK Imager tool onto my USB, that is my hard disk. So from there, I'm going to run the FTK Imager into the target machine, and then select the acquired memory option. Choose the location where you want to save the memory dump file. So we will include the page file as part of our capture, and click on start to begin the memory dump process. Then wait for the process to complete. And then subsequently we will check our results once the capture has taken place. Once the process is complete, you can analyze the memory dump file using FTK Imager or other forensic tools for evidence. Okay. So let's get over onto a Windows machine and see how all this fits together. For this demonstration, I have got Windows 10 machine, which is acting as my suspect or my target computer. I have attached a USB device to it, which is my one-touch hard disk. And if I came onto the file explorer of the one-touch hard disk, you will see that I have the FTK Imager folder in which the FTK Imager files are copied, which I'm going to run within this environment. So basically we are not going to install any kind of tool in the suspect or target machine. So whatever we are going to do, we will be using our own devices, and we'll try to pre-install the tools into our devices, and then we will connect those devices to the suspect machine. Okay, it has to be in the same state when we have seized the devices. Okay, once I'm now launched into the FTK Imager console, from our previous class you have already understood that how we can control this from either the file menu, which will allow me to capture memory, or I can use a toolbar on the top line which will allow me to do exactly the same thing. And it really doesn't matter which option you are going to take. You can access through the file menu, or you can go with the toolbar. Once you have selected the capture memory, you see that pop-ups a little wizard which allow you then to select destination path, so the location of where you want to save your memory captured file, that is memory dump of the machine. So in my case, I'm going to select the destination for the memory dump file. So let me browse onto the one touch of my hard disk, and within here I'm going to select make new folder, and I'm going to simply create a new folder as investigation. And within that I will create a subfolder as the name of RAM dump, okay, which will allow me to then capture the suspect RAM into it. I'm going to save the RAM dump into this particular folder. I'm going to select this folder as a destination for memory dump, and you can see that here that I selected the E drive and in the folders that I have created. And the destination file name by default is called memory dump.memory extension. And for this demonstration, I'm going to just leave it on the default setting it here. But ordinarily, I would change that, of course, to represent the target machine. I can also put a check mark on the include page file in here. And you can see that this will now also include the page file.system file, which also is usefully used in conjunction with my RAM capture. So should I require to analyze this within an access data tool, then I can also create a AD1 file called memory capture.ad1 by default. So I'm going to go ahead and capture the memory, which will then give me the progress bar and tell me exactly how long it will take for this to take place or to complete. Now the page file.system is in progress as we have selected this. Once the progress bar has told me that the memory capture and fetch file have finished successfully, I can simply close the wizard and then go and check within the file explorer to make sure that memory has indeed been stored in a file in a safe location. Okay, now the memory capture finished successfully. And here you can see on my one touch hard disk in the folder that I created, investigation and then RAM dump, that we have two files. One is memory dump and another one is page file, that is system file. So now for this demonstration, we would have noticed that the target machine is loaded with 37 gigabytes of RAM. However, of course, in a more modern system or the heavy or powerful machine, that would have taken a lot longer and would have required a lot more disk capacity in order to bring down. For example, you can consider as 64 GB RAM or else 128 GB of RAM. It depends on the system. Okay, this is something that you would need to bear in mind, of course, for the capture that you are undertaking, and not least the amount of time that it takes in order to take the capture. Once this have been successfully captured into your hard drive, it's a good idea then to use a hashing tool in order to hash the results, okay, to maintain the integrity of the captured files. So for that purpose, let's open the browser and let me browse for md5 sum, that is sum space windows. Click on the second link, www.pctools.net. Now click on this md5 sums12, that is zip file, and download will start automatically. So once the download is completed, extract the zip file and copy the md5 sum applicable to the folder where we have saved the ram dump file. On the search bar, type cmd and hit enter. So once the cmd console is open, then type md5 sum space memorydump.mem as displayed here. After md5, type the file name which you have given. In my case, it is memorydump.mem. and hit enter. Wait, now the hashing process is started. Once the process is completed, it will give an output of md5 hash value. Now copy and paste it in a notepad and save in the same location for the future use. And of course, all of this should be recorded in your actions, so you are dealing with this suspect or target machine or the seized machine. Once this have been successfully collected, then they can be passed to your forensic investigation team, or you can carry out the further analysis of it. So next, coming up, we are going to take a look on how to capture the registry settings from the Windows machine. Okay, that's it. Thank you. Capturing Windows registry with FTK Imager. So in this section, we will be capturing Windows registry using FTK Imager. So previously, we captured the RAM from the previous demonstration. Now we are going to use FTK Imager to conduct a protected files capture, that is Windows registry on our suspect or the target machine. And once that has taken place, we are going to, of course, go and check the results on our hard disk. Okay. So let's dive straight in with the demonstration or the practicals of capturing the registry using FTK Imager. Okay, so for this demonstration, I am using exactly the same environment as we used previously on our RAM capture practicals. If you are happy to see that our RAM capture was a relatively straightforward experience for you, then you will be very pleased to hear that registry capture or the protected files capture is equally as straightforward like RAM capture. Once again, you have two options. You can either conduct this from the menu bar, okay, under the icon that says obtain protected files, or you can come up on the file menu and protected obtain protected files. Select whichever one you want to choose. And here you will notice that when we come onto the obtain system files menu, that there is a warning from FTK that makes you aware of the fact that FTK Imager is obtaining the system files from a live system and not an acquired image. And this is a key point here in the fact that what you are actually doing is accessing live protected files from Windows registry that you would not normally be able to open within a live environment on the suspect machine. This might be particularly useful to you if you are trying to recover passwords, for example, or see the accounts which are currently being used. As we saw with the RAM capture, I am able then to browse to the destination, and let me create another folder inside the investigation folder onto my hard disk as a protected files folder. So I'm simply going to select that as that will be the destination for my registry files. Have been two options. I can take the minimum file for login password recovery or take the password recovery and all registry files. And I'm going to take the second option because I want a full capture, that is password recovery and all registry files, everything. Once that the actual export of this file is relatively straightforward and can see all of the different folders now being created and exported over onto my hard disk. If you take a quick look through File Explorer onto the hard disk into the protected file folders, you can see that indeed it has now captured those protected files directly onto the hard disk. I can also see a folder called Users, which I was not already aware would also then give an indication of the number of user accounts that are available to me on this local machine. So if I was not aware of the fact that there were how many users on this machine, I would now have an indication of the number of users. Once again, I can then take a look at this from a triage point of view, and I can also use Access Data Registry Viewer to do just that. Or this can be harvested off, hashed, and then pass on to my analysis team, the forensic analysis, for further investigation. Okay, so I'm hoping that this demonstration have highlighted how relatively straightforward and easy the tool FTK Imager is to use against volatile data such as RAM and against your protected files. Of course, this does not take away that it be a good idea to make sure that you practice this from time to time. Indeed, it's a very good idea to make sure that you get very familiar, of course, with the overall running of FTK Imager. That would then make this process very straightforward and easy thing to do as part of your overall digital investigation. Coming up, we are going to get a little bit deeper and more meaningful with FTK Imager when we take a look at capturing a live forensic image from a target machine. Okay, that's it. Custom content images in FTK Imager allow the analyst to add an evidence item and build a logical image containing only selected files or files of their choosing. That is nothing but custom content images. Okay. So what are the benefits of using FTK Imager to acquire custom content images? Basically, there are two specific areas of interest for us. The first is that we can apply these filters against a live image or a device drive. They may also be used against your captured images. Apply these filters against a live image or a device drive. This means that you can get straight in and target specific area of interest. Okay. So for example, if you knew that you were looking for a particular individual account on the suspect machine, or there were other files that you are interested in. So for example, only the documents or the spreadsheet or the images, graphics which were contained within the device of the suspect machine, you can target those files and you can filter using the custom content image selection. So for this purpose, we'll be using the custom content images. This is particularly useful if you wanted to do a quick triage or fast time support for the case. It invariably speeds up your acquisition time also, and therefore creates a much smaller image file. For example, if the data is huge, the image file size is huge, then by doing this custom content creation, you will only get the specified files, okay, the required files. So because of this, whatever the output will be there, it will be small in size. Okay. And so whereas previously when a full drive acquisition is going to be time consuming and invariably costly also, this is going to save your cost and time and therefore nullify the potential problem that you may have. Okay. They may also be used against your captured images too, and you can filter off or carve off specified areas either by folder or by partition, and or again by the different file types or by the individual accounts which are held in the captured image. Custom content image by file type. You use them by using a series of filters which can be used quite extensively by using either the wildcard. So FTK Imager allow the use of wildcards to filter and find specific files stored on the file system. This is a great feature if you are looking for a file by name, extension, or batch of files with similar names. Did not understand, right? No worries. Let's make it simple. See, wildcards are used in FTK Imager to search for specific file patterns in a file system or a disk image. For example, going against the file extensions that you are interested in, or you can go against exact match to the file names. Wildcard syntax. The syntax for wildcards in FTK Imager is similar to the syntax used in other tools and other programming languages. You can see the most commonly used wildcard characters in FTK Imager are listed on the screen. Let's see. The first thing is asterisk. That is nothing but the star symbol, which replaces any series of characters in a file name and extension. That means this matches 0 or more characters. Okay. For example, star.txt will match all files with a .txt extension. Understood? Next. Question mark replaces any single character in the file name and extension. That means this matches any single character, means only one character. For example, file ? .txt. Okay. So now we have only one question mark after file and before the .txt extension. That means it will match files like file1.txt, file2.txt, but not file12.txt. Why? Because we have used only one question mark. That's why it will find the files after the file name with one single particular character. If we add two question marks, then it will find if the file exists any two characters, it will automatically find. So this is about the question mark. Next, curly brackets. This matches a specific set of characters. For example, file and curly brackets. Inside the curly brackets, open the curly bracket 1, 2, 3, 1, 2, 3 and close the curly bracket. After that .txt, it will match files like file1.txt, file2.txt and file3.txt. Next, square brackets. This matches any one character within the specified range. For example, A to Z file.txt. It will match files like A file.txt, B file.txt, C file.txt and so on. Next is caret. This matches any one character that is not within the specified range. For example, caret A to Z. Next, file.txt will match files like one file.txt, two file.txt, but not A file.txt or B file.txt. Okay. Next, coming to the vertical bar. It separates directories and files. Okay. You can use this wildcard characters in FTK Imager's search function to search for files or folders that match a specific pattern. For example, if you want to search for all image files with either a .jpg or .jpeg or .png extension, you can use the search pattern in .jpg or .png type. We can see this demonstration later. It is important to note that FTK Imager only supports limited wildcard syntax. Okay, I repeat, it is important to note that FTK Imager only supports limited wildcard syntax and does not support advanced regular expression syntax. If you need more advanced search capabilities in FTK, or you may need to use a different tool, okay, or you can write a custom script to perform the search. So this is about the custom content image by file type. Remember that from the previous module, we spoke about the layout of the FTK Imager, and in the bottom left hand pane, we have the combination pane, which is hidden somewhere in between the properties pane next to the hex value, right? Now it's time to disturb that combination pane and do this demonstration, because this demonstration is completely dependent on that particular pane. Okay, so it will allow to make look at the properties, hex value and custom content. Because we are dealing with custom content sources, this will be the area where we will be working now. Just to make things easier for us, I'm going to left select the custom content sources. I'm going to drag this into a pane and then dock it so that we can then work within our custom content sources environment. A lot more easy and clearer to do. These are what we call dockable panes in the FTK Imager. So we can arrange the panes wherever we want. We can move from here to there, there to here. Okay. Now in a previous class, we took a live capture of the whole of the physical disk. That is when we was doing the FTK Imager, we were capturing the FTK Imager of the suspect machine, right? Where we collected the imaging of the suspect machine. That is disk 0, which would have taken the system partition and a recovery partition alongside the local disk C. Yes, the local disk C, that is the working partition of the suspect's machine. And that is because we wanted a bit by bit copy. That's why we collected that image, right? Now that would have taken some time and of course disk space to take that image. For this example, we are only going to be interested in potentially the documents which are available on the suspect's machine under a specific account. Okay, and those are going to be held, of course, under the logical partition or the logical drive on the C drive of the suspect machine. So for this example, that is going to be one of the filters that I'm going to target for my custom content. Now that I have ascertained this, here we will apply the custom content images by documents and by user SID, that is security identifier, which we learned in the previous module. Okay. So the first step is to add an evidence item, which I have two options for. Under the file menu, I can simply add all the attached devices. Now if I take this option, it will add all physical drives and also the logical drives which are known to this machine. So that may be useful if I was doing a filter across multiple devices or multiple drives. However, for this example, I am simply going to add an evidence item, as I have already ascertained the location of where my potential evidence is. So simply selecting add evidence item then brings me into the select source panel. This is a familiar pane to us, right? As you can see, that gives me the options of physical drive, logical drive, image file, and I'll be using this in the lab, for example. Or if I wanted a quick triage, it would also be for the contents of a folder. We already know about this in detail. We have already discussed this, right? If I were to select physical drive at this point, it would then list the attached physical device for me, and I would then be able to select from the top down menu which one I am particularly interested in. So if you are taking this option, once again make sure that you take great care and caution in selecting the correct physical drive. Okay. So for this example, I'm not going to take that option as I'm only interested in the C drive. So I'm going to use the back button and come back into the logical drive. Doing this then gives me the drop down menu of each logical drive known to this Windows device. I can see the logical drives correctly attached or known to this machine, and so we have the C drive. That is the drive that I am interested in. So that is the one that I am going to select. It now adds the logical drive to the evidence tree. And if I simply open up the C drive, and in the hierarchical folder structure, you can see where your information is likely to be stored. For those of you that are familiar with the folder structure of a Windows machine, you will then start to recognize some of the areas of interest potentially from your suspect's device. In this example, you are going to be interested in potential documents which are held under the user folder within this drive. And so here I can then see that I have got a specific user in as administrator. The administrator is my target. Yes, he is my suspect. I don't know whether it is he or she, but that is the administrator is my suspect. Is my target of interest for this particular demonstration. So if I open the administrator folders up, I would then be able to see all of the personal folders which are known to the administrator. However, as I do not fully understand where administrator may be storing the particular items I am interested in, I'm going to simply select the top level folder here, which is under the username administrator. You can see now that I also have a file list which has been represented to me quite nicely in FTK Imager, right? FTK is helping so much in understanding the files which is available in the suspect machine. Thank you, FTK. So to add this to the custom content sources, I simply right click to select the folder that is required and then select add to custom content image. And this is going to create an AD1 file. AD1 files are nothing but they are logical images similar to a container. So they are used to hold file level acquisition. However, they are not very common since it is a proprietary format. So we can call them as access data format also. Okay. So that is nothing but the AD1 file. Okay. Now that I have done this, you can see that this has now been populated in the custom content sources. And remember that we put this into this location just to make it easier for us to reference it and to see it. I can then select this and then edit the content and put in a variety of filters if I was interested in. So you can see in the wildcarding options, which is just pop up in front of the screen. Remember that we had discussed in the previous class of custom content image by file type. You use them by using a series of filters which can be used quite extensively by using either the wildcard, where FTK Imager allow the use of wildcards to filter and find specific files stored on the file system. Now it's time to use that. So in the wildcarding options, you can see that we have the ignoring case, include subdirectories, and match all occurrences. Within here, I would then be able to complete the script by potentially putting in the file extensions that I have interested in. So for this example, I'm going to simply strip out any PNG images which are underneath the folder of the administrator. I hope you guys have remembered the custom content image by file type. Under that, the wildcard syntax, where we have learned about the most commonly used wildcard characters in FTK Imager and how to use them. Now it's time to recall those characters and use it here. Hence, for this demonstration, I am going to use the asterisk. Yes, you are right, the star symbol. which replaces any series of characters in a file name and extension. Where we consider the example of star.txt will match all files with a .txt extension, right? So for this example, if you want to search for all image files with either a .jpg or .png extension, you can use the search pattern .jpg.png. Now we are going to use .png. This has now placed it nicely into the list of filters for my custom content sources. You can see from the menu pane that I can also then create new filters and indeed edit existing ones, or of course remove them. Once I'm happy that I've completed all of the custom content sources filters, I can then go ahead and create the image. I'm doing so the create image wizard pop-ups, and as with the creation of a full drive image, I now need to give the image destination. I'm going to go ahead and add the location and very quickly put in some evidence item information. So for this one, I will call as CI1, that is custom image 1, for example. Okay. But of course, I would then fill in the evidence number, unique description, and the examiner name and nodes in accordance with my local standards. The destination folder in this particular example is going to be backward onto my one-touch hard disk. And so I will now select my hard disk, that is E drive, from the location. Under the hard disk investigation, I will create a folder as custom image. Under that, again a subfolder, that is CI PNG, means custom image PNG. Once I have selected this, I can then OK add that, and it now becomes, as you can see, the image destination. I now need to give this a file name, which I will call as admin PNG. And again, you can see that what we have seen when we was capturing the image of the suspect machine, the same thing is here. That we created a full drive image that I can select the fragment size, compression rate, and whether I want to use encryption or not, the same thing. However, also included in this image creation, I have the ability to filter by file owner. I hope you guys remembered this filter by file owner, which we learned in the previous module, that is under the custom content image by user SID, by user security identifier. Now it's time to have a demonstration on that. For this demonstration, I am going to include the checkbox and I'm going to finish this. You can now see that I have the ability to choose the file owner which are known to this particular device. And at the top, I can see the two specific owners by name and security identifier of Dolly and administrator. Here Dolly is preferred as administrator. Yes, Dolly is my suspect. Okay, now I got the name for my administrator as Dolly. Okay, if I select administrator from the list, it will then only filter to those files which are owned by the user, my suspect Dolly. Once I'm happy that all my filters are in place, I can then also look at the options of verification, pre-calculating progress statistics, and create directory listings. Everywhere it will come. And I can then check mark this in accordance with my standards. Once I'm happy that all of this is in place, I can just simply start the acquisition process. Let's start. Because I have used very few filters in this example, this will not take very little image to actually create the custom content image, and no need to pause the class, pause the video and having cup of tea. Now I guess that is not required. Why? Because it will not take much time as earlier. And you can see that in no time at all it has now produced my hash. I can then verify this by closing this down and taking a look at the content of the image itself. So if I close down my image, I can take a look at the image summary, and here I can see the image verification results and of course other details about when this image was captured. If I come back over onto my hard disk, so using File Explorer to do this, I can indeed see the AD1 file which has been captured with admin PNG. I can also see the verification file under the text document and also the spreadsheet which has been created, which allow me to then view which image have been taken from suspect machine. I now have a very small image which contain all of the PNG images owned by my dolly, my suspect, or administrator under the administrator local folder. Of course, this would be a bigger file if I was to use multiple filters and did this across multiple drives. I now have my custom image for PNG. So this is how we will take the custom content images. So we have seen in the previous class that how we can use the wildcard syntax, where we have come across the asterisk, question mark, vertical bar, etc, etc. Now by using the asterisk, the star symbol, we discussed that the txt, right? Now we have taken the custom content image for the PNG file. Now similarly, let's try for .jpg also. Okay, so we'll have to follow the same procedure what we have followed till now for the PNG files. Now let me do the same procedure for the JPG files. As you saw, the wildcarding options of ignoring case, include subdirectories, and match all occurrences. Let me change the file extension from PNG to JPG. Okay, just replace PNG with JPG. So for this example, I am going to simply strip out any JPG images which are underneath in the folder of the administrator dolly. I'm doing so. Again, the create image wizard pops up. I'm going to go ahead and add the location and very quickly put in some evidence item information. So this one I will call CI2, that is custom image 2. Before we had CI1, custom image 1, now CI2. The destination folder in this particular example is going to be same as previous, that is my one touch hard disk. And so I will now select my hard disk E drive from the location. Under the hard disk, the investigation folder, I have pre-created that. Under that, the custom image, and then subfolder we have as CI PNG. Now let me create CI JPG. Once I have selected this, I can then OK that, and it now becomes, as you can see, the image destination. I now need to give this a file name, which I will call admin JPG. Before we gave us admin PNG. Let me check the filter by file owner checkbox. Okay. Here let me select dolly as preferred as administrator. I have to select dolly. Now it will start the process. way that we can collect different type of images for different type of investigations, and invariably when it comes to triaging and analyzing the results, FTK Imager will be able to give us the ability to quickly and effectively triage evidence, and is particularly useful in this environment. Remember that you can add your evidence by evidence items and or indeed by mounting images depending upon the level of the investigation that you are conducting. Within this environment, you can also view system file properties for a full forensic analysis. However, with FTK Imager, this is a manual process and could be quite laborious. If this is something that your organization or lab does on a regular basis, then invariably it is going to be more prudent for you to invest in the full forensic toolkit suite, because this toolset gives you the full capabilities and also automates the process by using in order to get the details very quickly and of the images that you have been taken. However, for this course we are going to use FTK Imager as a standalone application. We are not going to the forensic toolkit suite, and hopefully the following demonstrations will show you exactly how useful it is in triaging evidence. So we are going to look at viewing and searching through the captured images which we have taken in previous demonstrations. We are going to take a look at converting data, and so we will get into the 1 and 0 of a file and then move that over into meaningful information that we can use. We will also take a look at the way that you can save and export data from one format to another format. So let's dive straight in with the demonstration. Okay, so here I'm back on my forensic workstation, and as you can see I have already launched into FTK Imager. At this moment in time I have not included any evidence tree, so we are just taking a look at the blank console of FTK. Now I'm going to break this demo down into several parts, and I'm hoping that will show you different variations of how to add evidence and invariably gather information from it, either from a triage point of view or for a forensic investigation. And also this will highlight some of the area that we have discovered as we have gone through the rest of the course. So now adding PNG file. To begin with, I'm going to add an evidence item which is going to be an image file, which is based on the custom content image, which we collected in a previous demonstration. Now you may remember that this just holds the PNGs from a user called Dolly from the suspect's machine. Once I have located the file, I have now added successfully into the evidence tree. If I open this folder structure now into the area that I am particularly interested in, say for example root, we can also see the other panes within FTK Imager spark into life. So for example, I can see the file list with the subdirectories and any files which are connected within it. I can also see the viewer pane, which at this moment in time is showing me some hexadecimal output, and I can also see some of the basic properties of the pictures directory. Before we go any further, it is worth mentioning that the fact under the mode section the default setting is automatic. I also have the ability to convert to text and hex, and this is what is displayed in the viewer pane in the bottom right hand corner of the console. Remember that I can also gain access to this by going up in the toolbar, so you can see that I can convert between automatic to text and indeed to hex. Now if I leave it on the automatic setting, which is probably the best one for the particular demonstration, then the FTK Imager will ascertain the best output as per the different file extension that I am using. So for example, if we were looking at an image, it would display the image automatically for me. If it was another application and it was locally installed on my workstation, then it would display it within that application that is locally installed. If it cannot ascertain my file extension, then by default it will go into the hex value of the file. And so if I was interested in a particular image, for example, so let's come into one of the picture from the files on Dolly's machine. I can see that this is a PNG and automatically FTK is now displaying the graphic. I can also then convert this PNG file into text, which is fairness is not really going to be helpful for this file, or into the hex, which may be useful to me from a forensic point of view. And here I can see the start of an image on the PNG file in question. Now all of this is then going to be transferred over into the properties section in the bottom left hand side by default of FTK Imager, where I would then be able to come through and take a look at some of the finer details of the actual files itself. And this might be a particular use to me, especially when we are looking at date and time. Also of use it to me will be the verification hashes and some of the NTFS information, which is available to me, and you people can also see it on the screen. Now in this particular example, we are not going to get too hung up on the MFT numbers, that is the master file table. It is very much important and we will hold off as per now, and until we take a forensic look at an evidence item later in this demonstration. That time we will discuss a complete tutorial on the master file table will be in the upcoming clip. But of course what would be useful here would be the owner of the file, and here I can see the owner's security identifier SID and indeed the owner's name, administrator. Also included as part of this NTFS file would be the access control entries. So I would be able to see which account can actually gain access to this particular file. So I can see the built-in administrator and of course Dolly, who has got full control of this particular image. If I needed to take a closer look or this, or indeed share it or print it, I can export the file directly from the file list. This would need to have a destination folder, and so just to speed things up, I'm going to put this on to my desktop so that we can view it later. You can see here that it told me that one file has been exported successfully. Here is the exported file on the desktop called coming soon. However, also within Windows, I can take a look at the properties of the file, and within here I could then start to look at the specific details of date and time taken, who owns it, when was it taken, and by what, for example. So there would be a lot of different properties of course available to you depending upon the type of file that is in place. Remember that this may all be very useful to you as part of your investigation. Now coming to the multiple files export, if I wish to move multiple files, I can either do that by exporting the whole content of the folder by coming into the target folder and exporting files, or I can block select within my file list and I can then right select and export files using that function. Either way, it allows me then to move this onto my location and then view them by using normal Windows Explorer or the application which is locally installed, which allow me to view whichever type of file we are looking at. If I am interested in the content and viewing them one by one, then I can use this feature, multiple files export. Now adding a JPG file. Okay, let's wait. I have something to tell you guys. Till now, I have explained adding PNG file and viewing it in FTK, right? I don't know if you people have understood it or not, but I don't like it if you don't learn anything from this course. So for that purpose, what I have planned is, now I am not going to speak a word, and hence this part, that is adding a JPG file, will be muted. You people have to watch the complete muted part and understand how we can add custom content images. Okay, and I believe you will do it. All the best and enjoy the fasting for silence. Okay, I'm back. I hope you people understood the mute session of adding a JPG file. I don't know how many have understood or not. So to know about this, I have a simple way of getting those feedbacks. While giving the review of this course, if you like the course content, then please mention the mute session experience. I will surely respond to it. This is the only way I can come to know. Okay, and I will be waiting for your reviews. Okay, let's get back to the content. Now we are going to discuss about the image mounting. In addition to viewing the evidence tree, I can also mount an image, remember? And so if I came into image mounting and select the AD1 file, you'll remember that as an AD1 file, I can only mount it as a logical mount type. And the mounting method is file system read only. It will then give it the next available drive letter to Windows. Once I have created the mount point in here, I can then close this down and using normal file explorer come over onto the F drive. In this case, and take a look at the contents by just navigating as I would do normally through Windows. So we can have a look that the mounted image folder contains only PNG files. This is how the custom content images will help. Once again, this is a very straightforward and easy way to take a look at the contents, and indeed, if I needed to, I could then take a look at the properties. I can also manipulate this by printing them or sharing them with other users or other analysts. This is a very good way of quickly triaging against the contents of a folder or the contents of an image, and would be particularly useful in situations such as supporting fast time interview or providing other evidence within the evidence chain. Next, coming to the unmounting part, last part of this lecture. After the analysis or investigation, in order to unmount it, simply visit the FTK Imager dashboard and click on Unmount. It will then unmount the AD1 file from the system. In the next part of the demonstration, I'm going to add an evidence item, which is E01 file of the full image that we took previously in the course. We are then going to compare that with what we have just undertaken here and get into a little bit more depth and details from a forensic point of view. Okay, that's it. Thank you. When I open this up and add into the evidence tree, I can see the suspect PC all of the partitions which were gathered at the time of the acquisition. When I take a look at this, there should be no surprise in the fact that this is partitioned with NTFS, that is New Technology File System, as I would probably expect with a Windows machine. So before starting, let's check all the folders and files. If we compare this with our custom content image from the previous demonstration, where we were only looking at JPEG images from a user called Dolly, and I can now see all of the built-in and specific users within this machine. I would then be able to take a look at all of the users within the environment and of course all of the folders and all the files allocated to them. I am also able to see all of the system files which have been generated on this machine. Now, depending upon the level of investigation will depend upon how useful a lot of this material will be. But in general terms, the majority of this is going to be of little use to us when we are conducting normal kind of investigation. However, we are now able to search forensically across this machine rather than doing a quick triage as we did previously. As we are going to take a look at the second part of triage evidence using MFT with FTK Imager. So what is this MFT? What is this master file table? Let's understand this a little bit. The MFT is a database of every file which is held within NTFS and act as a fantastic reference point for us should we need to conduct searching across this whole image. It gives very comprehensive information about the files, and of course that also includes my suspect files that we may be interested in. We can go through the whole extensive folder and file selection and look for particular files and folders of interest. So this is about the MFT file. Now, for this demonstration, we need to find the MFT file. Now, how to do that? How to find the MFT file in the suspect drive? So simply, if I select the NTFS partition, inside the root, I need to search the MFT file. You can see that the MFT file or the master file table is then scanned and populated within the tool. If I left select the root folder at the top of the tree, you will then be able to scroll through until you find the MFT file, which is indicated by a MFT, that is with $symbol and MFT. This then allow me to come down into the previous pane, and if I am right select, I can then use the find function or control plus F in order to start finding and looking for different files and attributes across the whole system. So if I was interested in a particular file, for example, let's check for info.png. I could simply search on that to see its record within the MFT. Once a file has been located within the MFT, I can then start to take a look at some of the properties which are available to me, both from the hex and the conversion of the hex into property values. In order to do this, the first step would be to find the record holder or the magic marker of the file in question. The magic marker could be used as a generic term to refer to a tool or feature within FTK that is used to mark or flag items of interest within the evidence being analyzed. And this is found by locating the file 0 reference, which you can see indicated at the top. Once you have located the magic marker at the file 0 record, then you can use the offset to take you through the hex to find things such as creation time of the file change time, and the file read time. To do this, you need to find the hex reference, which can then be converted over into the properties pane. So to go to the offset by doing right click on the viewer pane or simply press Ctrl plus G, which allow you to then select the offset, which is 80, and keep decimal selected and ensure that you are in the current position. If you select the beginning of the file, it will search from starting. Similarly, if you select the end of the file, it will search from the end, from the bottom. Hence, ensure that you are in the current position and selecting the current position. It will take you to the location where the vertical bar is present. Let me redo it so that you people can find the difference. Please have a look at the highlighted section. Once I click OK, the vertical bar will appear on the highlighted section. I hope it is clear now. So this is the creation time of the file, where the vertical bar is present. Now select the line of hex or the 8 bytes, which then refers to the creation time of the file. Now in order to view this point, I need to come over to my combination pane and take a look at the hex value interpreter. You can see here that the file time has been given to me by date and time. Next, coming to the alternate time of the file, ATF. If I were to come across the next 8 bytes, it will then give me the alternate file time. Next, file change time of the file, that means FCT. And indeed, if I come to the next line, it will give me the file change time, and so on forth. And I can continue to select this entries, which will give me relevant times as we go through. Now the last part, file read time, that is FRT. This is the file read time that we are looking at, and once again it gives me the date and time, and this time it is an readable text rather than using hex. So to make you people understand and remember it better, let me add the box and highlight it. Okay. There are numerous entries, of course, that you can use by going through the MFT and taking a look at the values of each file. But remember that this is not the file itself. This is the MFT record that you are searching through. Now from this, how to recover data. Another great aspect of FTK Imager allows you to recover deleted or partially deleted files from the actual image. Remember that even when a user deletes something, unless it is been overwritten, you would still be able to gain access to it. And this also includes potential residues which is left in slack space. I'll try to show you demonstration of overwritten data, how it works. So one of the MFT attributes is the $data section. It starts with the code 0 into 80 and 000000, total 8 digits. Let's go back to the magic marker file 0, and by doing right click on the viewer pane or simply press Ctrl+F, which allow you to do a binary hex search for 80000000. This will point directly to the data section of the specific MFT record. Okay, let's click on find. So this part is little bit of mathematics, little bit of calculation, so I suggest you people to focus completely on this particular part. If you understood this part, then believe me, you can crack any case wherever FTK Imager is applicable. Obviously it will not do the advanced level of investigation, but if the open source tool, if we master this, then we can automatically take our investigation skills to the next level, and even we can learn the paid tools as well. So just focus on this particular part as it is important. Okay, the 4 bytes behind 0 into 80, I'll not repeat remaining 00, so please consider that. Okay, why? Because it will create confusion. So obviously it will have 8 digits, so starting number I'll just say as what it is. Okay, notice the length of the data section is 0 into 4800, which shows the length of the data section. When you highlight this 0 into 48, have a look at the hex value interpreter that is near the bottom left corner. We can see that the hex value interpreter converts this 0 into 48 to 72 decimals. Okay, now based on this, how we will find whether the file has been deleted or not. Okay, so to find whether the file is deleted or not, follow the steps. The code right next to 0 into 48 is 0 into 01. So now what this 01 is representing, what we have to consider by looking at this 01. So to make it simple, let's divide it into files and folders. Okay, obviously we will have the files and next is folders. So let's divide into two things. If in place of 01, if we get the values like 000 and then 03 and 04, then it will be stated as follows for the files section and for the folders sections. Okay, so the first thing, files part, the file section, the 01 means the file exists, means it is an existing file. If it represents 0000, that means the file is deleted, means deleted file. Similarly, the same thing applies to the folder section. If it represents 03, that means existing folder. Okay, the folder is present. If it is 04, that means the folder is deleted, means deleted folder. As the code right next to 0 into 48 now at present for this investigation is 01. So please answer what it is. I'll give you 10 seconds of time. Good. And I believe many of you have got the answer that the file exists, means the file is present in the image. then the pictures to be recovered have not been deleted from the hard drive. Information about the actual location of the picture on the hard drive is available in data runs, which start at byte offset 32 of the data section. In this case, byte offset 32 of the data section is 0 into 40. So what is this 32 of the data section? How we got this number 32, that is 32? Let's understand it. Have you guys remembered that we searched MFT attributes on the data section? It starts with code 0 into 80000000, 8 digits, right? And if we see at the right hand side of the viewer pane, the 4 dots before H are also highlighted along with 80, right? So we need to consider those 4 dots from there to the symbol which we have as @ I hope you guys can see this, right? And then the 4 bytes behind 0 into 80, we notice the length of the data section is 0 into 48. Now this 80000000 plus 48000000. So the 80 section have 4 digits, right? Consider 4 things, okay? And plus 48 also have the same 4. That means if we add both the things, we will get 8 bytes of offset. Okay, 4 plus 4, 8. And next in the deleted or not section, the code right next to 48 is 0 into 01, where we find that the file is present, the file exists. So that's 01. Remember, right? That's 01. Now this 01 till 0300 has 8 bytes offset. So 80 plus 48, we have 8 bytes, and then 01 till 03 we have 8 bytes. So 8 plus 8, 16. Okay, now we have identified 16 bytes offset. And remaining 16 bytes, we need to consider the whole line of 01, 00, 00, 00, 03, 00. Next to that, hyphen 0000, right? And next 05000. Now it is 16 bytes offset. As we are considering from those 4 dots there to the symbol @, if we count 16 plus 16 is equal to 32 bytes offset. That's how we got the number 32. Understood? So for your reference, I will again make the columns sections and I'll put a box and highlight it so that you can understand. Okay. In this case, next to the byte offset 32 of the data section is 0 into 40. Please have a look at the highlighted section near the left side corner of the property pane. Once I select 40, the hex value interpreter converts this to how much? Yes, right, 64 decimal. I hope it is clear now. As the hex value interpreter converted this to 64 decimals, now go to byte offset 64 from the beginning of the data section, where you will find the data run with information about the first cluster of the picture data. Many times the data run starts with 0 into 31 and ends with 0 into 0. But this is not always the case. In this case, the data run starts with 0 into 31. The code next to 0 into 31, in this case it is 0 into 6, which shows the number of clusters belonging to the pictured data. That is, once I highlight the 06, the hex value interpreter converts this to 6 decimals. Okay. This means the data of the picture fills 6 clusters. Next to 06, the next 3 bytes, that is 0 into 10, D0, 0C. shows the number of the cluster. The hex value interpreter converts this to 8,39,696 decimals. So let me note down this in a notepad. Okay, I'll forget this numbers and all. So let me note down. And the decimal is equal to 6 clusters. Next, 3 bytes 0 into 10 D00C, which is 8,39,696 decimals. Which means number of clusters. Okay, now get back to FTK and click on the volume name in the evidence tree pane and the properties tab next to the value hex value interpreter, which shows the size of one cluster is about 4096 bytes. Let me note down this too in a notepad as cluster size. That is 4096 bytes. So let me do some simple mathematics. Multiply cluster into cluster size. Okay, we need to multiply the cluster with cluster size. That is 6 into 4096. Okay, let me open the calculator so that we will not miss any number. Okay, so 6 is multiplied by 4096, which is around 24,576. Now you know the starting cluster is 8,39,696 and the size of the photo is 24,576 bytes. Forget everything. I just want you people to remember the starting cluster, that is 8,39,696, and the size of the photo is 24,576. Okay, for the reference I'll pin this both the numbers on the screen until we complete this calculation. Okay, so you'll come to know where this starting cluster is used and the size of the photo will be used. Okay, now click the volume name in the evidence tree pane and right click the viewer pane. Now select go to sector or cluster and enter the starting cluster number. What is the starting cluster number? Please remember. Okay, I hope you guys have remembered. That is nothing but 8,39,696 as we are already displayed on the screen. That is, we have to enter in the cluster search box and then just hit OK. It will take you to the location where the vertical bar is present. Please have a look at the highlighted section. The vertical bar appeared in the highlighted section. I hope you people can able to see. Once we highlight the section where the vertical bar is present, the file header of a PNG file appears in the viewer pane. So we come to know that we have the PNG file. Okay. Now right click the viewer pane and select set selection length. And enter 24,576. What is this 24,576? That is nothing but the size of the photo. Yes. Which is nothing but the size of the photo. I hope you guys have remembered this. It is also displaying on the screen. Now right click the selected data and click on Save Selection. In order to save this picture data as a file, I'll add it to my desktop so that we can gain access to it quickly. And also I can show you live. Let me save it without any extension so that we can have a look at whether FTK itself provides the original extension of the file as we save it, or whether we have to add the extension while saving it. In some cases, the application may automatically add a default extension to the file, such as .txt for a plain text file. This is common in application like Notepad on Windows. If just you enter the file name and if you don't add the extension .txt, it will automatically add that txt extension if you don't specify. Okay. As we can see, we managed to save the file without an extension, which causes issues when I try to open or use the file. Many operating systems and applications rely on file extensions to determine the file type and how to handle it without an extension. The system may not know what kind of file it is and may not be able to open it correctly. Okay, so let me add .png extension and save the file. Good. Now I can access the file. It is generally a good practice to include an appropriate file extension when saving files to avoid potential issues.